Logistic growth is kind of like population boom. Population boom can take off at a really fast rate, but eventually it's going to level itself out. That's what a logistic growth function does. Logistic, they use in the model things that have a real quick growth, but then it decreases the growth over time. So it has an increase and then a decrease as it levels itself out. Really easy things to think of. This is kind of what it would look like. It increases fastly and levels out. What is something you can think of that probably makes a lot of sense that has increases real fast and then it tails out over time?
Will it ever decrease?
What's that?
Like if it will increase the tail off and decrease?
The rate at which it's increasing tails out. That's what I mean by
But it will always increase.
It increases, but then it turns to a decreasing growth rate, but it doesn't like drop to nothing. I mean, within a set period of time.
Like sales or something.
Yeah, that makes sense. What about like when an iPhone comes out? Spikes and then drops off. I saw that. But yeah, you're right. The ecosystem carry, what is it called? Carrying capacity. Yeah, carrying capacity. It only can have so much before there's nothing you can't have anymore. Otherwise, it just dies. Yep. And then dinosaurs get the same thing. We get gas. It's fossil fuels. What? You hate me. It's great. So here's what these look like. It's kind of a pretty interesting graph. They're very easy to model with. We're gonna have a kind of a crazy looking equation though for them. When we do this stuff, there's going to be this point at which it changes. The point at which they call it the maximum growth. There's going to be a formula to be able to figure out what that ordered pair is for all of these types of functions that we look at. This is one of the sections that's in the modeling thing that the other classes really don't wind up doing because there's it has an exponent that we wind up solving for, and there's a lot of natural log stuff that we do. So for you guys, it's more fun.
More practical.
Yeah, it's actually pretty cool. It's really easy to work with. So let me show you what the formula looks like and how we set it up and how we get this maximum point and how you pick parts out of it. It's another one of these days of pretty straightforward stuff. You have an equation that will look like this. And it follows all of these rules. Now, I don't want you to write out all of the rules here. What we need to look at is, because you're going to have a calculator. Within the calculator, you're going to be able to distinguish where that horizontal line is. You're going to be able to figure out most of the things. What you're going to have to be able to do by hand, really, is find that point at which the maximum growth rate's at. So we have this equation, y equals some value over 1 plus a e, what is it, to the negative rx. R is your rate. Obviously, it's going to be as a decimal, just like we've done in the past. You have a y-intercept. Your y-intercept is going to be at c over 1 plus a. So my equation here for the example, where's your y-intercept going to be? 2. Very good. Okay. But again, it's going to be something pretty simple for you to be able to figure out because what you have. Calculator. If it's charged. Excuse me. Domain is all real numbers, and it's going to be bounded range-wise between 0 and 0. Because it has that aspect that's going to approach that horizontal line.
Wait, between 0 and what?
C. Whatever that C value is. Remember, it's got that horizontal asymptote at C.
Okay.
And then the only other thing is to get that max point. And this is where it's weird. That max point's going to be at the natural log of A over your rate, comma, C over 2. And if you think about it, between 0 and C, it's going to be the halfway point.
Yeah. What is that? Above R, what's above R?
Natural log of A.
Okay.
So if I want to look at a problem like this,
So the rate would be 0.5, not negative 0.5, right?
correct. Excuse me. So if I want to go through this one here, we know that a rough graph. Where's your 2 horizontal asymptotes? 6 and 0. That's why.
That's not that bad. So you're always gonna have 1 and 0 then?
Yeah. We know we have a y-intercept where?
Is that the E like the function E or?
Yep.
Okay, because that was confusing. Yeah, we got like 4.
It's exponential. That'll be what? And then to figure out your growth point, we know it's going to have to be at somewhere. It's going to occur at 3 for the y value. You just got to figure out the x value. So in order to do that, you take the natural log of a. Our a value here was what? 2. And you divide that by your rate, 0.5. So in the calculator, it's just natural log a over. But when you hit natural log in your calculator, does it automatically pop up as a decimal? I'm sorry, as a fraction
No.
or parentheses?
Oh,
Yeah,
parentheses.
Okay. As long as you close your parentheses before you divide, you'll be all right. Or you can just type it as a fraction.
Where's this natural log second?
Right next to the 4.
Alright, I got it.
It looks like N.
Yeah, that's what, honestly, that's what I think.
So it was a natural log. A was what? 2?
Dude, it looks like an I.
Looks like
It's in,
You're an
it doesn't
You're
look
all
like it on theirs.
in Milwaukee.
It's so weird.
It's over.
Or it goes over.
R.
I kinda like this one more than those.
And it's doing that. That's basically it. Yes, ma'am. It's half of C. The y value will get half of C. Oh, it's like that. To be honest with you guys, when you're graphing these things, it's really, really simple. And the only other thing you could do is obviously we could put it in the calculator itself. So let's see, alpha y equals 6 over 1 plus 2 e negative 0.5x. Oh, I'll probably have to change my window a lot. Yeah,
Looks good.
yeah, sweet.
They look the same.
Oh, I didn't turn it off yet. Oh well. But yeah, you guys get the idea. It's gonna be pretty simple to work with. Yes, ma'am.
Back to the rate method, is that like
No, it's the formula itself.
Oh, okay.
Yeah, it's not that the rate itself is 0.5, but it's just they use the negative. And to be honest, do we need to go through the whole showing of why they derive it this way for us? No, we really don't. It's just another function that we can use in the model. It's just it's another one like you're saying, I forgot what it's called. Environmental thingy.
Yeah, the carrying
Carrying capacity. You know, my carrying capacity for life holds no boundary.
Oh, how sweet.
Good.
Well,
That was bad. I mean, for me, even that's bad. Do you need to do another? Yes, ma'am.
Wait, is like C where
I
the
don't-
caps off?
Mhm.
That's
That's what's the that's
Okay,
what's
so
gonna
that's
cap
that's
out.
the height.
Yeah. Yeah. Do you want to do another one?
Well, no.
What?
Okay.
No.
So the other part of this is solving for x. Graph it. Yes, you could.
You'll find it somewhere.
Sooner or later, right?
Exactly.
Guess.
Yes.
Yes, and check.
That's
You go with
good.
5. That's gotta be 5.
That's gonna end up being like 4.
That's so exciting.
There is not a regression button for this one. So this one you'll have, it's more of the, it has to be kind of told to you that you have a little bit of it to make it work. Or if you remember the type of styles you have, like population growth, things like that, things that tail off over time. Or if you're looking at the data sets, you can kind of see how it increases real quick and then it decreases.
There's gotta be a rule when it's supervised.
Excuse me.
Or something.
What's that?
Nothing.
Bless you. Thanks.
So,
So what do you want to do? Is this fraction equal fraction?
kind of stuff.
Yes. Switcheroo.
Switcheroo. Yeah. Subtract 1 and what do you get? So this is 5/4. Subtract 1, what do you get? 1/4. Now what?
Can you divide 10 by 8 or not?
What's that?
Can you divide the, can you get rid of the 10 by dividing?
Yeah.
Oh, yeah, then do that.
So at this point, would it have been easier to leave it? I mean, it doesn't matter. You have a calculator. What do you press?
I don't know.
You don't.
The division button.
Thanks. Thank you. Thank you. I just sarcasm.
I thought he asked, what do you do to divide by 10?
No.
Well, I was gonna say do
divide by 10.
this 0.25. You divide it by 10. What do you do with the decimal? Move it over a spot.
Sure.
No.
No.
I learned that trick back in like 5th grade.
No.
So anywho, so you have 0.025 now. Is e to the negative 3x. How do you undo an e?
Wait, can you just plug it into the calculator? Do you have to do that first?
Or you could just do
Use the calculator.
You're over.
Just show us. Don't listen.
How do you?
1/4.
What was it? How do you undo e?
You log. No, you don't log it. That's
Yeah, natural log.
You natural log it. Woo. Natural log it.
I forgot the
I knew that one.
So you natural log it.
I'm still convinced it's I.
It's gonna.
I still
Every
write-
time I write it out as I.
Yeah.
Pissing me.
Stop doing that. So you take natural log. You have natural log of 0.025. Divide that by negative 3. And you get that. So it was not 4 or 5.
Close.
Yeah, you're really close. Yes. You're going to get really ugly fractions for a lot of decimals and stuff like this for a lot of these because of the fact you're doing natural log stuff.
5, 6.
What happens a lot with these is it is just another way of solving for x. And I know we probably did some of, when we did exponential growth, exponential decay, we had some solve for x stuff way back when. I just don't think we did it in terms of having a fraction thrown on it, thrown with it as well. But by now, I think you guys can probably solve a 4 or 5 step equation. I hope. Yeah. Well, actually, you even need to use paper if you have to solve for x here. If you know the steps in which you have to do this, couldn't you go right to your calculator and do it?
It's supposed
But
to
I
be.
don't want to confuse yourself.
That's fine, then write it out. which is good. It's better to try to write out what you're doing prior to doing it, because that way you don't screw up.
Let's see.
I'm try this only calculator.
Go for it. Try it on a calculator. So you know, just write the calculator. See if your mathematical skills have become
I think I'm
most excellent.
I'm already stuck.
I don't know why I feel it then.
Whoa.
Can I look at previous examples?
That's
Of course.
I think I got it.
Got it.
Okay. Nuh-uh. Nuh-uh. Nuh-uh.
Ouch.
What did I do
Oh,
wrong?
yeah,
What
it's
did
right
you
at
do?
10, 9, 9.
Why'd you get?
No, this one doesn't actually.
What does that have?
I'm just, it's literally the same thing. Just wait for me to IN it.
I don't know.
Just wait for that.
You're an
On
L.
here, it looks like an I. On here, it looks like an I. Yours has an actual.
Boom. Look at it.
Mine has an L, like a lower, like a capital L.
Ours is
Mine
not.
did.
It's
It's
like
just
an
a
I.
straight line. But
You're just a lower.
Oh, you know why? Because they were saving money when they're printing the keys.
there's just
That actually sounds right.
Do you know that the cost of these things have not changed in 20 years? They're always $135.
This is like $70.
What'd you get?
When I had one, they were like $135.
This is like $70.
Well,
7.225.
I don't lose money.
I just don't put I in.
The yellow ones, school property. Why are they on eBay? Oh, I don't know.
723 then.
Did you guys get .7229?
Yeah.
0.72.
I did it all on my calculator. Let's go.
2, 9.
No one cares, Cody. That's
I
not
got
good.
0.72.
I was trying to find it.
So when we do this, we get 10 over 9 is 1 plus 2e to the negative 4x.
Yeah, I got you.
So this becomes 10
Oh,
over 9
I know what I
and
did.
minus 1 all over 2. Take the natural log of that and then divide that by negative 4.
I thought it was 20.
And it should work.
Single-handedly brought me to that.
What's that?
We were down 3 at cash.
I wonder if you could just type that straight in. That's pretty cool looking.
Let's do that. Wide open for like 6 seconds. Missed it. Leaving it wide open. They get the ball. They get away.
Do a complex fraction interval. Oh, you can. This is sweet.
I don't even know where to write.
I think all the conversions.
X equals.
Doesn't that look cool?
Unless there's an index.
Aren't you Avery?
Yes.
All right, so let me show you how this is going to work then in terms of a data set.
C over 1.
Let's see if you guys write this up first, and we'll go through the actual question pieces I have here. So here's a population growth style. Ooh. Here's a population.
Equation for X.
Yeah, let's do an L1, L2. Actually, you know what? There is a second point about that. I was going to try to show you guys how this works. I don't remember if it's on.
I forgot how to do that.
Yeah, there is a.
Let me get out that sheet.
Yeah, we want to clear out our lists right away. You can do an L1, L2. So reset your lists. Remember how to do that?
Yep.
No, I just pushed
Are we
it.
gonna get this? I mean, take a quiz or test or anything? Is it
Do you
without
really
this?
need it?
I'd be kind of like lost.
I don't know.
Well, it just.
Press the button on the back. Wait.
But
For the reset, are you?
We talk about like every.
I know how to reset it. Just
Press the button.
give me my calculator.
Reset button.
You know, if you do it this way also, if you just want to, because I know some of you guys had problems where you had the L1 and the L4, your lists had disappeared. If you do a hard reset, a lot of times it de-garbles what was in here. I don't know if there's a better way of saying that. Some of these things can get pretty messy, especially if you forgot to do like turn a plot on or off. you're resetting stuff through, if you're done a bunch of problems and you come back to it, you know, we did this Friday, which means none of you guys did it until this morning when you're eating breakfast, or last hour, or when you got here at 7:30.
Yeah.
So you probably forgot how to reset some stuff or how things worked out. Hard resets always work. Okay, hard reset always works too. So if you go to your stat edit, L1, L2, let's see, 0, 20, 30, 40,
We're on
50,
Colorado.
3, and then L2 is 11, 421, 7, 4, 7,
Oh, I thought it would have been tons every time.
158, 8, 8. Button pressing. All right, so window 0.
I got this.
It doesn't show it very well, does it? Yeah, it doesn't. Mine doesn't really show. It doesn't show the tail on it. I wonder how. I wonder if we zoom it out a little bit. It might show a little bit better.
Would you go for the scale
But I
for the
kind of
Y?
see it.
I went with 10,000.
I went with 3.
I put my minimum. I put my minimum at 10,000,
Yeah, that's what I did.
and then I did
My
my
max
scale
was
at 10,000. I did 300,000 for my max. I'm trying to figure out how I can get it to show that.
0 to 20.
It's not
And
good.
then
What do you have it at?
I put X 1 regular and Y 0 to let's see,
Huh?
down to
My X max is 60. It doesn't show.
It doesn't really show very well.
All
It
it
looks.
shows is this.
Yeah, it's kind of what it looks like on mine too. I'm trying to think if we send it out, even if we go out further.
You press draft.
Yeah, kind of. Mine's a little bit like that too. It's just. Yeah. All right. I guess the easiest thing to notice is what they're trying to show you here. If you start walking through your differences, Error, what's wrong?
just a bunch.
Did you reset your lists?
Show me just
Oh, you need to declare your Y equals. That's the quickest thing to check if you're getting an error is clear out your Y equals.
all over plus.
So we have this in here. This is one of those that you have to remember that
Oh, it says B.
the population one, bacterial growth, things like that.
So that way we don't have to do like
Point, negative
we
point.
gotta like choose which one we want to do.
This one would be easy. This can be tough to see unless you had it already graphed for you. You know what I mean? Because it's easy to show you how it graphs. If I show you a graph, which one would it model out as? If you see one that goes increasing and tails out, you're going to realize, oh, that's going to be logistic. So now I got a couple questions to look at real quick. There is logistic regression on here. Log reg, I think, or actually it's just logistic.
Yeah.
It's
So if we hit stat calculate, and I think it's mine's B.
yeah.
Yeah, B is.
You're right. Hit enter. This one takes a second to calculate. It's thinking. Oh, I'm logged out, so I'm not doing it. So this is giving me a formula. So I have A at 23.5,
I didn't get
766. B at point. Yeah, go ahead. putting the cap at, I'm raising it up to 1 because I'm thinking that C value here, we're talking about people, aren't we, population? So,
I think you should just
0.7, 3/4, all right,
Well, am I second?
maybe.
Do I count?
Am I half?
You're like
you're like
9/10.
Yeah, well, you
0.97.
could be like 11 twelfths.
My turn.
Sure. Alright.
I'm like a 0.97.
Apples and oranges.
How many decimals?
Apples and oranges are not the same thing.
One of the things that I would do when I'm going to write equations out,
Tomato, tomato.
when they're giving me off the regression formula, what I would usually do is 3 or 4 decimals because I'm going to get a better approximate when I go to figure out the questions. If you do 2, you're going to be close, but the more decimals you can give the calculator to do it, the better you're going to be. It's not like you're just rounding to give me an answer. The less rounding you do up front, the closer you're going to be when you do your rounding at the end. If you rounded this to 0.58, it's going to be a little bit more. It's going to be a little bit more often. I mean, here I wouldn't want to do 0.1 because there's so much of a decimal there. So I try to use 3 to 4 decimals when I'm taking these values to put it in my y equals because it's just pressing a couple levels, just to be a little bit more on the safe side. All right. So if I do that and go to my y equals, and we're going to put in that our awesome formula. So we're going to have an alpha y equals fraction, and I get 316,441 over 1 plus a 23,5766 e to the negative. Oh, they call the b value as our r, I believe.
Yeah.
So that'll be 0.1026 and then x. Hey, and if you did it correctly, according when you look at your stat file now, see how the line goes right through your points?
Hold up. What's the equation again?
My
So you
turn.
have 23.5766
Yeah.
over.
So this is
Wait, B is R.
yeah. They're calling BR. Let me put this in my calculator also and show you guys. I should have done it already. I don't know why I didn't do
It's
that.
alright. I forgot what C was.
C is that. Yeah.
What I do for what?
So what do you do?
Actually, let me do this.
Mine's already just too high. Mine's like
Oh, I'm gonna guess those 12 points.
316,000.
God.
That's like even in the negatives.
Really slow descent.
It's just so ugly. I don't even care. Oh my god, during the part when you had to type them in.
Oh, isn't it awful?
Yeah.
They're all even numbers.
All right. So then we did.
It's just approaching 0. 6.4. Wait, that's a 3 negative 5.
So slow.
4.
All right. So we had that.
Never going to receive.
At the time, I tried, I definitely got a lot better.
So slow down. Yeah. It was good though.
All right. So this is what it looked like. Now when I go to my y equals, here's what I put in.
Mine didn't, and I gave up. I had mine negative
316,441.
And again, I didn't put it in the same.
It's the negative. What is it, 102.66 or 6, and then x. Now, if you did it like this, you'll notice that your line, this is what I wanted to show you, your line is going right through the points there. Bless you. Bless you. So now you can kind of see that it's, by putting that line in there, you can kind of see how it's tailing itself through. It's a little bit easier to see. Yeah, it's going to wind up tailing itself out. Does that clear that out, why it looks like that?
Yes.
So the other part on that question was, based on the equation, what will the aurora population approach in the long run? So the equation you got, what is it approaching? What's its maximum level it's going to get to?
361,441.
Your C value. It's approaching your C value. Okay? The 316,441. And then based on the equation, when would the population first exceed 300,000 people? So what are you going to do?
Table.
Table.
I'm already there.
Okay? He's a little confident in himself there.
We're at 6 now.
Just can't keep.
So if I'm looking at your table then,
6-0, I think.
what did it do?
6-0.
You're just scrolling through to figure out, so
Good luck.
yeah, your buttons are a lot faster to press than this one, drive me nuts. Okay. Let's do a couple of these. I love these. There's a great question in here. You guys are gonna laugh at it. This is 8-8. Let's see. So this is page 521. Let's do 33, 3, 4, 35, and then 8. So I gave you 2 graphs, handful of solve the equation, and then 3 of them that are using the model that you put in the calculator and answer a couple of questions. Okay. Remember when they're talking on there, you don't have to graph it, but I want you to just, I mean, you're using your calculator to do that. You don't have to graph it on paper, but it asks you about when did it reach its maximum growth. That's how you find that ordered pair. Okay, so make sure you remember how to get the ordered pair. That's about the goofiest thing you have to remember with these. So how to find that ordered pair. Okay? Okay. Tomorrow we'll do sinusoidal stuff, which is how you look at sine and cosine. How we can look at that. You guys have done that already. We've already written the equations off of graphs. We've done that. But the goofy part is how do you take it from a table? Sinusoidal graphs are ones that are periodic, like monthly things that look at annual things, like when it talks about every month over, like, I don't know, temperature averages. No, temperature averages kind of tend to be the same, hence why they're average, even though they're going up. But
You said we don't have to graph, right?
no, you just use your cal. These 2 I want you to graph by hand. These 2 are the graph by hand. That way you get your plot of your asymptotes and you get your maximum point. I just want you to get to the idea of how you do it.
It's like, I was just like, I tried something.